Today we're going to discuss 3 different questions about the topic of meteorology. The first one being, describe the formation of precipitation and explain the differences in rain, snow, sleet, and hail. So, precipitation is going to form in one of 2 processes. The first one is collision coalescence. In collision coalescence, precipitation must be larger than 20 micrometers. The bigger droplets are going to fall faster and connect to smaller droplets, and this is going to cause them to coalesce, which means to connect. And now these droplets are going to fall even faster, and they're going to continue to stick to others, and they're going to get thick enough to where they're able to fall on the ground before they're able to evaporate. Then there is aggregation. Aggregation must have both ice crystals and really cold water for it to occur. The ice crystals are going to collide with the really cold water and will end up creating an even bigger ice crystal, and these are going to drift through the clouds and connect and keep forming. Next, we are going to discuss rain. So rain is going to form during coalescence, and it is when water droplets fall to the ground. This can occur whenever droplets combine together and they end up being heavy enough to not be evaporated before they are able to hit the ground. Next, we have snow, and snow is ice crystals that fall. Ice crystals are going to form in the atmosphere whenever it is below freezing, and they will fall as snow as long as the atmosphere remains below freezing until they hit the ground. Next, we have sleet. Sleet is also rain, but it's rain that's going to freeze before it hits the ground, which causes that little thin, slippery ice that we get on the roads here a whole lot in Oklahoma this time of year. Next, we have hail, and hail is going to come from the cumulonimbus clouds, those tall clouds that extend up higher into the atmosphere. These come from the high clouds in the sky where the temperature is below freezing. So in the process of this, the droplets are going to be taken upwards, and they're going to combine with other droplets, and they'll end up creating hailstones. And these often form in unstable atmospheres, these cumulonimbus clouds that create this. So next we're going to talk about the weather fronts, and I'm going to sketch and label the 4 types of fronts and give you general weathers for each of them. So a cold front is cold air that replaces the warm air at the surface, and they can bring quick wind direction change and clear skies at times. During a cold front, the temperatures can actually drop more than 15 degrees within the first hour of one. Cold fronts are also a lot more, I guess you could say dangerous than a warm front, and they happen here a lot in Oklahoma. I'm sure everybody who lives here has noticed lately that we'll have a day where it's warm, like today, when I'm recording this, but here in a couple days it's going to be freezing cold again because that cold air is going to push the warm air back up and out, and it's going to cause the dry and bitter cold again. Next we have warm fronts, and this is when the warm air is going to replace the cooler air at the surface. Now these tend to be less violent than the cold fronts, and they also tend to move a bit slower than a cold front does. They do, however, tend to often trigger storms, and they make the air a little more warm and moist. These warm fronts can also be linked to what is called a frontal inversion, which is going to be where the warm air is going to end up overrunning the cooler air. Next, we will discuss a stationary front, and this is going to be a front that doesn't move, and when it does move, it's only going to move a small amount. With this kind of front, the air is relatively dry, and there's not going to be any precipitation fall. However, there are times where if there's a lot of water vapor, the warm air mass can cause a significant amount of rain or freezing rain to occur. And also, with this type of front, the winds on either side of the stationary front are often parallel to the front itself. Now we will discuss the occluded front. And this type of front is when a cold front catches up to a warm front and then it overtakes it. These often take place when a storm is going to end or it's going away. You will often see these occluded fronts whenever they are in low atmospheric pressure, and they will end up producing precipitation because of the cumulonimbus or nimbostratus clouds that are present during these fronts. Lastly, we will discuss the question of why is lifting air important, and we will discuss two of the processes of lifting. First process being the orographic lifting. This lifting is when the air is forced to lift up because of some sort of mountainous barrier. As you can see in this picture, the moist air is going to rise and then it's going to go up over the mountains, and as it does this, the dry air is going to be what descends, and this is often why you will see one side of the mountain that's going to flourish and then the other side's going to be kind of dry, as the professor said in her video. And whenever the air mass starts to get higher in altitude, it quickly cools down adiabatically and turns the relative humidity up to 100%. And this will create clouds and even precipitation sometimes. Next, we will discuss frontal wedging. And this is when masses of both warm and cold air are going to collide. And the cooler and denser air is going to act as a barrier, and it's going to force the warm air to rise up, as you can see in this example picture. And with this type of lift, as the air rises, it's going to cool, and as the moisture begins to condense, it's going to produce clouds and precipitation with it. So as you can tell through both of these examples, airlifting is going to be what creates our clouds and often precipitation. And it's done because as the air parcels rise, the excess water vapor is going to condense large aerosol particles, and cloud droplets are going to grow and end up growing by condensation in the rising air. And this is why airlifting is important, because without airlifting and without this process, we wouldn't have the clouds or precipitation that we need in order for us to have water in general and be able to grow crops and things of that sort. And that is all I have for you today, so thank you very much for your time.